All right, so number one, they give us a graph of f of x, and there's a bunch of things over here we have to determine. Okay, I like to first just write down what's going on the left side of our graph as well as the right side. So on the left, we can see our graph is going to continue to go down, and on the right, we can see up over here it's going up. All right, so the first part says determine whether f of x represents an odd degree or an even degree. Now remember, for an odd degree, our function is opening in opposite directions. So see how one side is down and the other side is up? That's going to be an odd degree. Whereas if it were even, it would be up, up, or down, down. They'd be opening in the same direction. So because this is opening in opposite directions, right? One side's down and one side's up, this right here represents an odd degree function. Okay, so now we have to determine the sign of the leading coefficient. Okay, whether it's negative or positive. Well, to determine that, we only look at the right side of the graph. If this were pointing down, right, down would be negative. But because the right side of the graph is pointing up, that's going to have a positive leading coefficient. Okay, part C, determine the number of relative maximums. Well, for relative maximums, we're looking for something like this. See how the graph kind of makes like a bump, right? It goes up and then it starts to come down. This is where a relative maximum would be. And we can see we have another one right over here. So altogether we have two of them. Okay, here's the first one and here's the second. Okay, and then part D, describe the end behavior of the graph. Okay, so we want to start off this way. As x approaches negative infinity, and it's important to write all this out. This means as we go to the left, right, as our x values get smaller, aren't we going to the left on our graph? What's happening to f of x? What's happening to our y values? Well, let's look on the left of the graph. Since this says down, it's heading towards negative infinity. All right, whereas as x approaches positive infinity, this means as we're going to the right. So as the x values are getting bigger, right, as we go to the right on our graph, what's happening to f of x? Well, the function itself is going up, so it's approaching positive infinity. All right, number 2, it asks which statement regarding the function below is incorrect. Okay, I want to just underline that to point that out. All right, so number 1, there is one relative maximum and two relative minimums. All right, I labeled them on our graph just so we can see. For the relative max, we're looking for, right, the top of a bump where the graph is going up and then starts to come back down. This right here would be a relative maximum, so there is one of those. And relative minimums, we're looking for the graph is coming down and then starts heading back up. So it's kind of like the bottom of a U, maybe you could call this. So we have two relative minimums, one here and one here. So choice 1 is true. We're looking for which is incorrect. So that's not our answer. Okay, now I decided to write down up and up. What's going on either end of our graph, on the left side and the right side, because that's going to help us with choice 2. Choice 2 says as x approaches negative infinity. So as we're going to the left, the y values are approaching positive infinity. So the y values are going up. And look, that is true. As we go to the left, we have the word up. As x approaches positive infinity, so we know that means as we go to the right, the y values get bigger, right? They're approaching positive infinity. Well, since this is also saying up, this statement is true as well. So choice 2 is not our answer. Okay, as far as choice 3, the degree of the polynomial is even. So an even function opens in the same direction on the left and right. So if we look on the left, see how this is up and this is up? Since they both say up, it's opening in the same direction, that would be even. Also, if they both said down, like if it said down and down, that would also be even. The only way it would be odd is if we had one, like let's say the left end of our graph opening down and the right opening up, or vice versa. So since this is opening in the same direction, right, up and up, we could say this is even, so that's true. Okay, so choice 4 is going to be our answer then, and let's just take a look at it. There is a negative leading coefficient. Okay, so to decide whether the leading coefficient is positive or negative, we're only concerned with what's going on the right end of our graph. If on the right, it's opening up, it has a positive leading coefficient, and if it's opening down, it has a negative leading coefficient. So since this is opening up, our leading coefficient would be positive, not negative, so choice 4 is the incorrect statement. All right, now let's take a look at number 3. Which graph has the following characteristics? So I labeled what each of these means. Okay, so 3 real zeros. Your real zeros, right? Zeros are where the graph intersects the x-axis. So if we start there, we can see choice 1 has 1, 2, 3 zeros. Choice 2 has 1, 2, 3 zeros. Choice 4 has 1, although there's multiplicity because it's bouncing off, so it has 1, 2, 3 real zeros. And choice 4 has 1, 2, 3 real zeros, again with multiplicity here. So that doesn't really help us. Okay, so I guess these last two clues are going to help us. So it says, as x approaches negative infinity, which means as we go to the left, f of x, our graph, approaches negative infinity, which means it goes down. So if we look on the left, it should be going down. So here on the left, it's going up. So choice 1 is not our answer. Okay, choice 2. On the left, that is going down. So that could be the answer so far. Over here, choice 3, on the left, it's going up. That's not our answer. We're looking for the left going down. And then choice 4, right here on the left, we're going down. So it's between choice 2 and 4. All right, now this, as x approaches positive infinity, so as we go to the right, f of x, our graph, should be going up. So let's look on the right. This is going up, so choice 2 is going to be our answer. If we were to take a look at choice 4, see on the right it's going down. That's not what we want. We want on the right to be going up. So choice 2 is our answer. Number 4, a sketch of r of x is shown below. An equation for r of x could be which? All right, well, let's see. In order to figure out the equation, let's first look at the zeros. We have a 0 at x equals negative c. So that means we have a factor at x plus c, right? Now, before I go to my next one, I just want to point out, see how it's bouncing off the x-axis, right? It comes down and then bounces back up. That means we have multiplicity. So let me put a square on that factor. Right now, if we have a 0 at x equals negative b, that means we're going to have a factor at x plus b. And if we have a 0 at x equals positive a, we're going to have a factor at x minus a. Okay, we just reverse the signs. So you just want to see which answer choice says r of x equals this. So it looks like it is right here, choice 4. All right, so let's take a look at the next one, number 5. The graph of a cubic polynomial function. Again, remember, cubic just means x to the third power. F of x is shown below. If f of x is written as a product of linear factors, kind of like number 4 was, which factor would appear twice? So we want to know what would appear twice. I'm actually going to scroll back up. For example, see how we have a square on this factor? That means technically there's 2 of them, right? This x plus c times x plus c, that would appear twice. So we're looking for where the graph is bouncing off the x-axis. All right, so in number 5, we could see it's bouncing off the x-axis right here at x equals positive 1. Okay, so this is at x equals positive 1. Now, if we have a 0 at positive 1, we know the factor, we're going to reverse its sign to give us x minus 1. So choice 2. All right, number 6, which expression is a factor of this expression? Now, first of all, we have 1, 2, 3, 4, 5 terms. So we're not even going to be able to do factor by grouping because if we even tried to group anything, right, like, look, there's a leftover term. Okay, you have to have the same number of terms in each group, so that's not going to work for us. So we got to get rid of that. All right, so what we're going to do instead is I actually went through and you could see I took this and even though we can't see the whole thing, plugged it into y equals and I'm going to hit graph. All right, now we could see, sorry, I know this is shaky because I'm holding this iPad up, but we can see that it appears that there's 0 at negative 2. This looks like there's one a little bit further than positive 2, and then there's one on positive 3. It's kind of hard to see, so I'm going to go to my table of values. So if I hit second graph, we're looking for, okay, now we could see at negative 2, we have a 0. So that means x plus 2 has to be one of our factors. Now, I'm looking here. Look, x plus 2 is a factor. So I'm not even going to go any further. That right there is our answer. Okay, if x equals negative 2 is a 0, then x plus 2 has to be a factor. All right, so let's take a look at number 7. Let me see if I can get this off the screen, this calculator. All right, so number 7, which of the following has a factor of x plus 8. Okay, so if we know if we have a factor at x plus 8, then we're going to have a 0 at x equals negative 8. So, I mean, honestly, what I would do is I would put these in my graphing calculator one by one and just go to the table of values and see which one shows when x equals negative 8, the y value is 0. Okay, so what I did here was I graphed each one of these functions in the graphing calculator one by one, and I went to the table of values and I wanted to see which one had a 0 at x equals negative 8. So you could see choice 1 at negative 8, the y value is not 0. Same thing at choice 2. Now if you look at choice 3, when x is negative 8, the y value is 0. So what that means is choice 3 has a 0 at x equals negative 8, so, meaning that we have a factor of x plus 8. So choice 3 is going to be our answer. Number 8, which graph represents a polynomial function that contains x squared minus 2x as a factor? Okay, well, let's first take a look at this. This right here, right, we could factor that further. Can't we pull an x out of each of those terms? So if we pull out an x, that's going to leave us with x minus 2. All right, so these are our two factors from what they're giving us, x times x minus 2. Now, I mean, I can tell that these are not the only two factors, because if there were only two factors, we would have a quadratic, which graphs to be like this, right? But here we see we have a cubic, another cubic, a quartic, and another cubic. So these are just two of the factors. Now, if these are two of our factors, right, we know that we have a 0. I'm going to start with this one. If we have a factor at x minus 2, don't we have a 0 at x equals positive 2? Okay, and if we have a factor of just x, that's the same thing as like x minus 0 or x plus 0, we have a 0 at x equals 0. So we're looking for which of these graphs have a 0 at 0 and 2. All right, so this one does not have one at 0. This one doesn't have one at 0 or 2. This one has one at 0, and it has one at 2. So choice 2 right here is our answer. And let's just make sure this one doesn't. It has one at 0, but it doesn't have one at 2. So choice 2 would be our answer. Okay, so number 9 wants us to find the zeros for f of x. Now, we could do this algebraically or we could do it graphically. Sometimes graphically does not give you all of your answers, but I'm looking at the answer choices here because these are all whole numbers. We could do it either way, algebraically or graphically. So I'll do it both ways. Let me start with algebraically. Okay, so first thing we want to do is we want to set our function equal to 0. And then all we're going to do is just factor, make a t-chart, and solve. Now, I know that some of you may see, all right, look, we have 4 terms here. Let's jump right into grouping. But before we jump into grouping, remember, if you could factor out a greatest common factor, we want to do that. And we can pull an x out of each of these terms. So basically, when we do, each of our exponents are just going to go down by 1. So in the parentheses, I'm writing what I'm left with. Okay, so now that we've factored out the greatest common factor of x, this x is just going to keep coming down. And let's group. All right, so out of these first two terms, we could pull out an x squared, which would leave us with x minus 4. And then out of the next two terms, well, the biggest number that divides evenly into both of these is a 9. But because this is a negative in front, we're going to pull out a negative 9. And that'll also leave us with x minus 4, because negative 9 divided by negative 9 is positive 1, so we have positive 1x. And then positive 36 divided by negative 9 is negative 4. So let's close that parenthesis, as well as, see this parenthesis here, we have to close that one too, and bring down the equal 0. So it looks like we're on a good track because these x minus 4's match. So because these match, we know x minus 4 is going to be one of our factors. We can take what's in front of the x minus 4, so this x squared minus 9, and group that as another factor. And then this x that's hanging out in front has to come down and bring down the equal 0. You need this. If it's a show your work question, you need this the entire time, okay? You have to keep it in an equation. All right, now it's up to you. You could make a t-chart from this point, or If you prefer to factor this further, you can. Either way, you get the same answer. So I'm going to actually factor this further using dots. So this would factor to x plus 3 times x minus 3. Okay, and then we'll take this x minus 4 and just bring it right down. All right, and from this point, now that it's fully factored, we are making our t-chart, and we are going to solve. All right, so under the x, we write x equals 0. Underneath, if we have a factor of x plus 3, our solution would be x equals negative 3. Under the factor of x minus 3, we have x equals positive 3. Okay, we're just reversing the signs. And then the 0 that corresponds to the factor of x minus 4 would be x equals positive 4. Okay, so it looks like that is choice 3 right here. Now, you could do it graphically also, or you could do it graphically in addition, right? It's always a good idea to check. So I'm going to actually show you in my calculator how to go about that. Okay, so first thing we want to do is go to y equals, and we are going to plug in our function, okay? Now, when you hit, you could just hit graph right here, top right, and if you look here, you could see that, look, we do have zeros at negative 3. It's kind of hard to see this one because what's happening is it looks like our graph is coming down, up, down, and up, but it does come down and hit the x-axis at negative 3, and it comes back up and hits it right here at 0. It goes up and down and hits it at positive 3, and then it hits it at 4. Okay, so we have negative 3, 0, positive 3, and 4. And if that's hard for you to see, remember, you could always hit the second button and then graph and just go to your table of values. Okay, I got to scroll down a little, but let me see. Okay, so we have a 0 at negative 3, and at negative 3, we have a 0. And as we scroll down, we have another one at 0, right? 0, 0. We have another one at 3 and another one at 4. Okay, so you could always look at your table of values to find the solutions also. Number 10. So when factoring to reveal the roots of the equation, which equations can be used? Okay, so I mean, they're saying they want you to factor this to reveal the roots. So let's go ahead and do that. Okay, so if you look at each of the terms, there's nothing that we could pull out of all 4 of them. But since we have 4 terms, we can do this. We can factor this by grouping. So to the first 2 terms, right, these 2 terms, I could pull out an x squared, which would leave me with x plus 3. Now out of the next 2 terms, we want to pull out a negative 4. And the reason we pull out a negative is because this first term here is negative. So when we do that, that also leaves us with x plus 3. Okay, so we know that if these x plus 3's match up, we're on the right track. We could take what's in front of them and group them as one of our factors. And I'll bring the x plus 3 down. So now since this first parenthesis shows dots, right, a difference, and these are both perfect squares, we can factor that further. So we would factor that to x plus 2 and x minus 2. And then we can bring down the x plus 3. Now, if you were to solve this, right, you would make a t-chart at this point, and you would wind up with x equals negative 2, x equals positive 2, and x equals negative 3. Okay, so now they wanted to know which of these equations could be used to solve this original equation. Well, if you look here, see, I'm going to actually use a different color to match this up. Doesn't equation 1 match up exactly with this step right here, right? Doesn't this say the same exact thing as equation 1? So equation 1 can definitely be used. I'll put a little check mark next to equation 1. Now, equation 2, if you look at equation 2, it doesn't say that anywhere within our work. But think about this. See how in equation 2 they both say x squared minus 4? When that happens, can't we take what's in front of them, so the x and the plus 3, and group that together, so we'd have x plus 3, right, times the common binomial here, so x squared minus 4. And isn't that what we have right here? X plus 3 times x squared minus 4. Okay, again, since the x squared minus 4's match up, that's one of our factors. And then you take what's in front of them, so the x plus 3, and you group it as another. So, I mean, you know, this right here is equivalent to what we have right there. So equation 2 works out. Now, take a look at equation 3. Equation 3 does have the x squared minus 4, like we have. But this says x minus 3, and we have an x plus 3. So equation 3 is no good. That one's not going to work for us. So it looks like choice 1 says 1 and 2 only. All right, so in number 11, they want us to determine the zeros. So what I did to start was I took my equation and set it equal to 0. All right, so now we basically just want to factor, make a t-chart, and solve. Now, it doesn't say that we have to determine them algebraically. So you could try to determine them graphically if you'd like. Keep in mind, the biggest exponent is a 5, so we can have up to 5 solutions. Okay, so if we want to try it graphically, you could go to y equals and plug in the function. And when we hit graph, oh, that's kind of funky. So remember, we can have up to 5 solutions, and I'm not really seeing 5 solutions. So I'm not exactly sure what's going on here. So I can always hit second graph, right? Second graph. And let's see. Well, it looks like we have a 0 here at negative 3, 0. We have one at 0, 0. Just scroll. We have another at 3, 0. And then the values are getting super low negative. So I'm really only seeing, as I scroll up and down here, 3 zeros, not 5. So I'm not going to depend on this graphically, because what that means is the other 2 zeros might be at irrational values. Okay, so let's do this algebraically instead. So when we look at these 3 terms, we could clearly say they're all even, so we could pull out a 2, and they all have x's, so we could pull out an x. Now, since our leading coefficient is negative, that's when we pull out a negative. If your leading coefficient was positive, you would pull out a positive 2x. All right, we're going to be pulling out a negative 2x. Okay, so that's going to leave us with positive x to the 4th, right? Because a negative divided by a negative is a positive. Here, positive 34 divided by negative 2 would be negative 17. And because we pulled out an x, like each of these exponents are just going to go down by 1. So this x to the 3rd will be x squared. And then negative 144 divided by negative 2 would be positive 72. And we did have an x right here, but we pulled it out, so we have none left to put here. So I'm going to close up my parentheses. Okay, so we know this negative 2 is going to keep coming down. And here, we are not going to do the rainbow. If you want to do the rainbow, go for it, but I highly do not recommend to do it if you don't have to. So because the leading coefficient is a 1, this is where we just set up 2 sets of parentheses. If our first term is x to the 4th, we're going to put x squared here and here, because x squared times x squared gives you x to the 4th. And we just need to come up with 2 numbers that add to negative 17 and multiply to positive 72. So that's not too bad, right? Negative 9 and negative 8. All right, and if you'd like to factor this further, the x squared minus 9, that is a difference of perfect squares, so you could factor that one further. You don't have to, though. You could jump right into the t-chart. That's up to you. I'm going to factor further because I'm finding most people seem to like to do that. So this right here would factor to x plus 3 times x minus 3. And this last factor does not factor further. Even though we have a difference, and x squared is a perfect square, 8 is not a perfect square. So that we're just going to bring right down. Okay, so we can make our t-chart. All right, now, what we'd like to do is we set each factor equal to 0 and solve. So I'm going to take negative 2x, set it equal to 0. I'm going to actually do these the long way, just so you could see how we're getting our answers. All right, so we're going to take the x plus 3 and set that equal to 0. The x minus 3 and set that equal to 0. So I'm going through this a little slow. And we're going to take the x squared minus 8 and set that equal to 0. And what we have to do is just solve these 4 equations. Okay, so let's start over here. if you want to get the x by itself, this says negative 2 times x. The opposite of times would be division, right? So we're going to divide both sides by negative 2. And that way, these cancel out, giving us x. And 0 divided by negative 2 is just 0. So there's one of our solutions. Okay, in the second equation, to get the x by itself, we would subtract 3 from both sides, leaving us with x equals negative 3. Okay, and we already knew if we have a factor of x plus 3, you just take the opposite sign. So you get x equals negative 3. Right? Whereas with this factor, we should wind up with x equals positive 3. And the reason why is because if we add 3 to both sides of the equation, you get x equals positive 3. Let me write that number again. That looked kind of messy. All right, now over here, I'm going to add the 8 to both sides of the equation to get the x squared alone. So that gives us x squared equals 8. And then to get rid of a square, we take a square root. Now remember, this exponent of a 2 tells us we should have 2 answers. So when we take the square root, we get x equals positive and negative. That's where those 2 answers come from. Okay, so I know at this point in the year, some of the classes were told that they can just leave this as radical 8, can bring it down as radical 8. But other classes, right, especially if you're in the honors class and other classes, we went through how to simplify a radical. So if you leave it as plus and minus radical 8, that's okay for right now. But whenever you have a radical, we want to write it in simplest radical form. So I'm going to break this down into 2 more radicals, and I want to try to find the biggest perfect square that divides evenly into 8, which would be 4. So the radical 8, I'm going to break up into radical 4 times radical 2, which is okay to do because radical 4 times radical 2 is radical 8. So these are equivalent. And then let me break down the x equals plus and minus. Now, since the square root of 4 is 2, we're going to replace this radical 4 with a 2. And we're just going to take this radical 2 and bring it down because there's nothing else we could do with it. So here, we'd wind up with x equals plus and minus 2 radical 2. So we have 5 answers: 0, negative and positive 3, negative and positive 2 radical 2. So we did wind up with 5 answers. Okay, now number 12 is different than number 11. Number 11 asks us to determine the zeros. So we had to take our expression and set it equal to 0. This does not say determine the zeros. It says factor. So please do not write equals 0. We don't have an equation. There's no equation to solve. They just want us to take this expression and factor it. Okay, so our first step in factoring is, can I pull out a greatest common factor? Well, they're all even numbers. Whenever everything's even, you could definitely pull out a 2. You can look and see if you could pull out anything bigger, like a 4 or something, but 38 is not divisible by 4. So we're going to just pull out a 2, which would leave us with 6x squared minus 19x plus 10. Okay, when we pull out a 2, we're just dividing each of these numbers by 2. All right, now the 2 is going to come down. Now in this one, since the number in front of your trinomial, in front of the first term of your trinomial is something other than 1, this is where we do the rainbow. Okay, everyone with the rainbow, what we do is we multiply together the first and the last number to give us 60. And we are eventually going to have to find 2 numbers that multiply to 60 and add to negative 19. Now, when we do the rainbow, we do not, see this? We do not do this. Boom, boom. We do not set up 2 sets of parentheses. What we do instead is we bring down the first term, we bring down the last term, and when we find those 2 numbers that multiply to 60 and add to negative 19, we put them in the middle here, okay, and we attach this variable, we attach an x to it. So those 2 numbers are going to be negative 4 and negative 15, right? So negative 4x and negative 15x. And you can put that in whatever order you want. It doesn't matter. Okay, so let's bring down the 2. Out of these first 2 terms, we could pull out a 2x, which is going to leave us with 3x minus 2. Out of the next 2 terms, we could pull out a 5, but you have to decide, do I want a positive 5 or a negative 5? Well, since the first term of the pair starts with a negative, we're going to pull out a negative 5. Okay, which will also leave you with 3x, minus 2. All right, so let's just write our final factors. So this 2 comes down. We take what's in front of the common parenthesis, so the 2x minus 5, and we group that together. And we take the 3x minus 2 and write it once and once only. This pen is giving me issues here. And that would be our answer. Okay, number 13 wants us to algebraically determine the zeros, so it lets us know that we have to take this function and set it equal to 0. And then when we're done, they want us to check our answer graphically. Okay, so now I know when we have 6 terms, right? I know some of you are tempted to rearrange and write it in standard form and combine like terms, but when you have 6 terms, please don't. It's lined up nice and neat for you. The only time you want to rearrange and write in standard form is if you're given a polynomial with 3 or 4 terms. Other than that, just leave it as is. Okay, so what we have to decide is, do we want to group it in 3 groups of 2, or do we want to group it in 2 groups of 3? Well, I mean, by looking ahead, I can see, I'm not sure if everyone can see this, but we have a 1 in front of the first term and a 4 in front of the next term. I'm not worried about signs, so 1 and 4. And if you look at the next 2 terms, this is an 8 and a 32. So if we took an 8 out of each of these, wouldn't that leave us with a 1 and a 4? And out of the next 2 terms, if we took out a 12, wouldn't that leave us with a 1 and a 4? So if you can't see that, you may have to try both types of grouping, but if you can see that, I mean, if it jumps right out at you, then you can just say, all right, well, I can see here that I'm going to be making 3 groups of 2. Okay. And again, if you can't see that, no big deal. You just try it out both ways and see which gives you the same expression within your parentheses. All right, so out of the first 2 terms, we're going to pull out an x squared, which is going to leave us with an x squared minus 4. Okay, out of the next 2 terms, we can pull out a positive 8x. And when we pull out the positive 8x, we could see we are also going to be left with x squared and minus 4, so we know we're on the right track. Out of the last 2 terms, we could pull out really just a positive 12. And please don't just write 12, right? Don't do that. We have to put the plus sign in front of it. And when we do that, that leaves us with an x squared minus 4. So we know we're on the right track because all of our parentheses here say x squared minus 4. They say the same thing. Now, because they say the same thing, we can take what's in front of them, so this x squared, this plus 8x, and this plus 12, and we can group them together as our first parenthesis. And then what we're going to do is we're going to take this common binomial factor of x squared minus 4, and we're going to rewrite that once and once only. Okay, now from this point, you want to look and say, can I factor further? Now, if we look in the first parenthesis, right, that's a trinomial. There's 3 terms. And since the leading coefficient's 1, it should be pretty straightforward. Okay, we don't have to do a rainbow. We just do the AM method. We need to come up with 2 numbers that add to 8 and multiply to 12. So 6 and 2, right? So we can factor this to x plus 6 and then x plus 2. Okay, and if we look at the next parenthesis here, this is just dots, right? We've seen this a bunch of times already. So that would just factor to x plus 2 times x minus 2. And let's just make our t-chart and solve. All right, so we wind up with x equals negative 6. X equals negative 2. Another x equals negative 2. I mean, if you don't want to write it again, you don't, because technically it's the same solution. And then x equals positive 2. Okay, so if I were to put this in curly brackets, I'll do it over here. We'd wind up with negative 6 and positive as well as negative 2. So we really only have 3 solutions. Even though it's a 4th degree polynomial, we really only wind up with 3 solutions because we have a repetitive solution. Okay. So they wanted us to check this graphically. Okay, so what I did was I plugged the function in my calculator, and here's the graph. Okay, we could see it is a 4th degree function, right? It goes down, up, and it goes through the x-axis right here at negative 6, negative 2, and positive 2. Now, it doesn't actually go through the x-axis at negative 2. It actually comes up and bounces off. So remember, when it bounces off, that's when we have multiplicity. And that's why we have 2 of the same factors and a repetitive 0. So this checks out. Okay, number 14. The first part wants us to algebraically find the 0. So, I mean, we've done this a bunch of times. We take our function and set it equal to 0. All right, so if we're going to do this algebraically, let's factor. So since there's no GCF out of all 4 terms, we could jump right into factor by grouping. So out of the first 2 terms, we pull out an x squared, which would leave us with x plus 2. And out of the next 2 terms, we could pull out a negative 9, which would leave us with x plus 2. And since these both say x plus 2, we could take what's in front of them, so the x squared minus 9, and make that our first factor. And we could rewrite the x plus 2, once and once only, right? Now, the x squared minus 9, at this point, we should be recognizing, right, this is a difference of perfect squares. So that's going to factor to x plus 3 times x minus 3. And, we can bring down the x plus 2. And if we were to solve and make a t-chart, you don't actually have to make the physical t-chart if you don't want. You can just write your solutions. You get x equals negative 3, right? We reverse the signs. We get x equals positive 3. And we get x equals negative 2. Okay, you can just write them right underneath the factors. If you prefer to make the t-chart, like if you prefer to do this, go for it. Okay, so negative 3, positive 3, and negative 2. And if you want to put those in curly brackets, you can. That's up to you. Okay, now part B says, on the set of axes below, they want us to graph y equals p of x. Now, we should know right off the bat that because these are zeros algebraically, that is where our graph should intersect the x-axis. So before I even try to graph this, we should know that we're going to have a 0 at negative 3, positive 3, as well as negative 2. Okay, and then honestly, you can just go to y equals in your calculator and you can plug this function in right here, and you want to go to the table of values to figure out which points you want to graph. Okay, so let me bring this back up and let's do that. Okay, now this is the table of values I got, and you could see these y values. I mean, this only goes up to 10 and down to negative 10, I believe, if I count that out. So instead of, even though along my x-axis I'm jumping by 1s, along my y-axis I'm going to jump by, I think, a different interval here. But along the x-axis, right, this would just be negative 1, negative 2. You don't have to number them all, negative 3. And then this would be positive 1, positive 2, positive 3. But along the y-axis, to make some of these values fit, I think we're going to have to jump by something other than 1s. I'm actually going to jump by 4s. So I'm going to make this 4, 8, 12. Let me number up to 24, I guess, right? Something like that. So 16, 20, 24. And let me do the same thing in the negatives. So this would be negative 4, negative 8. Sorry, it comes out a lot neater on paper, right? When you have a little more space to write. Okay, so there we go. So what I'm going to do is I'm going to plot whatever points I can. So it looks like at negative 4, negative 14, we could fit that on the graph. So at negative 4, we're going to be down at negative 14. So right there. I'm going to get my pen. So negative 4 is going to be at negative 14. We already have 3, 0, negative 2, 0. So now let's graph negative 1, 8. So at negative 1, I'm sorry, we're going to be down at negative 8. So right there. At negative 1, we'll be down at negative 8. At 0, we're going to be at negative 18. So at 0, we're going to be down here at negative 18. At 1, we're going to be at negative 24. So at 1, we're going to be at negative 24. Now, I know this isn't showing in my picture, but it also shows that I'm going to scroll down. At 2, we're going to be at negative 20. You know what, let me actually add this to the chart. At 2, it says negative 20. At 3, it says 0. And then at 4, we're at 42, which I can't fit on the graph, so I'm just going to plot these last couple points. Okay, so at 1, we're at negative 24. We just did that. At 2, we're at negative 20. So that's going to be right here. And at 3, we're at 0, which we just said. Okay, the announcements are coming on, so I'm just going to graph this and then stop. I'm just going to connect these and stop. Okay, so there we go. And I just want to point out one thing. Please make sure you label it. You could just put P of X. You don't have to write the whole entire equation. And either put arrows, or if you graph to the end of the coordinate plane, like let me just show you. If I go all the way to the end here and all the way to the end here, technically you don't even need arrows. But you know, if you want to be safe, you could just put arrows on the end. Okay, so when we look at part C, it says describe the end behavior of P of X. Now, I kind of shrunk this because I wanted to be able to see the graph to answer this question. Now, whenever they're talking about end behavior, we want to know what is going on as we look at either end of our graph. All right, so if you look right here on the left of the graph, we're going to continue to go down. And if you follow it all the way to the right of the graph, you can see it's going to continue to go up. So I started off my end behavior like this. As x approaches negative infinity, so that means as we go to the left. Now, be careful that you don't say f of x or y. This is specifically p of x. So if on accident you write f of x, that's not correct, okay? You want to say what p of x says. So as we go to the left, look at this, we're going down. So p of x, if it's going down, is going to approach negative infinity. All right, and this means as we go to the right, as x approaches positive infinity, our function p of x approaches, well, as we go to the right, look at this, it's going up. So p of x is approaching positive infinity. Okay, and I'm just going to emphasize that. Please make sure that since this is p of x, we put a p of x right here. And this just means as we go to the left, it's going down, right? As we go to the right, it's going up. So as we go to the right, it's going up. All right, now letter D says determine the relative maximum value of p of x, and they want us to round it to the nearest hundredth. Now, for the relative maximum, we're kind of looking for where it bumps up and then starts to come back down. So see right here, the graph goes up, 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 and then it hits this maximum point right here before it starts to come down. This right here is called our relative maximum. Okay, so let me just make this smaller. We are going to use our calculator to do this. And you should still have the function in there from before when we graphed in part B. And what we're going to do is in our calculator, I'll kind of show you my fingers. I'm going to hit second trace. And we're going to choose choice 4 because we're looking for a maximum. So I just like to hit the number 4 rather than scroll down and hit enter. So I'm hitting the number 4. Now, our relative maximum is right here. So they want us to give it, see how it says left bound? You just want to make sure your cursor is to the left of this point. Now, right now, I don't see my cursor, but that's because it's at 0, negative 18. It's at 0, negative 18. It's all the way down here, which is off the graph. So I need to move my cursor over here to the left of the maximum. So I'm going to use the X arrow, the left arrow key, until, see, now we see it. I'm so to the right of it, so to the right of it. Now I'm just about on it. I'm going to keep going until I'm clearly to the left of the maximum, which is like right there. Okay, then I'm going to hit enter. Now it says right bound, so I'm going to use my right arrow key and move to the right of that maximum and hit enter again. And when it says guess, we hit enter again. And the maximum value is the height of the graph at that point, which would be right here. And they want us to round that to the nearest hundred, so that would be 1.38, right? That's 7 is going to round that 7 up to an 8, so 1.38. All right, and there we have it. Okay, so number 15, on the axes below, sketch a possible function for p of x, where a, b, and c are positive. Okay, so first of all, we could see here that if a is positive, but it has a negative in front of it, that tells us we're going to have a negative leading coefficient, okay? Okay, so now if we look at this, this says x minus b squared. So if this is x minus b, it means we have a 0 at x equals positive b, and that square tells us that we have multiplicity of 2. Okay, and then if we have a factor of x plus c, that means that we have a 0 at x equals negative c. All All right, so let's take care of this. I'm gonna start here. If we have a 0 at x equals negative c, that means it's gonna cross through the x-axis at negative c. If we have a 0 at x equals positive b, it's going to cross through the x-axis at positive b. And if we have a negative leading coefficient, it means our graph on the right is going to end off going down. So it's going to point, it's going to come down. I'm actually going to, I think, draw this backwards. Now, just keep in mind, if there's multiplicity of 2 at x equals b, it means that it's going to kind of come up to the x-axis and bounce off the x-axis. And then it's going to follow through this way. Okay, so because we have a negative leading coefficient, it's going to go down, up, and it has to end off going down if it's a negative leading coefficient. Okay, so let me graph that. So it's going to go down through negative c. It's going to come up to b, but not go through the x-axis. It's going to bounce off, and then it's going to end off going down because of the negative leading coefficient. And that's it. And you could just label it p of x. You don't have to label the whole entire function on there, as long as you label it. All right, number 16, which statement regarding polynomials and their zeros is true? So the first one gives us f of x equals this, and it says it has zeros of 1 and negative a only. All right, well, let's take this and set it equal to 0. Okay, so to solve this, we could see right here that this is dots, so we could factor this to x plus 1 times x minus 1. And I'm going to bring down the x plus a. And it equals 0, and now we can make our t-chart. So the zeros would be at x equals negative 1, x equals positive 1, and x equals negative a, because we reverse the signs. So they're saying we only have zeros at 1 and negative a only. They forgot about this one, so that one's not our answer. Okay, the next one. So this function has zeros of 4 and a only. Okay, so let's do the same thing. Let's set this equal to 0 and solve. Okay, so I'm going to do grouping. I'm going to pull out an x squared, which leaves me with x minus a. Over here, I could pull out a positive 16, which would also leave me with x minus a. Okay, so then we can group together the x squared plus 16, and we could rewrite x minus a just once. All right, now, we cannot factor this one further because of the plus sign. And this just says, I know this is messy. Let me see if I can kind of get in there a little. This says x minus a. So if I make a t-chart, underneath the x minus a, we'll wind up with x equals positive a. And on the left side, I'm actually going to take this and set it equal to 0. And when I solve, I'm going to subtract 16 from both sides. Leaves me with x squared equals negative 16. And then I'm going to take the square root and look at that. What happens? X equals, well, we have a negative under the radical. And we're going to learn how to deal with that later on in math. But as of right now, when we have a negative under the radical, we know we have a non-real answer. Okay, you can't have a negative under the radical and wind up with a real answer. So when they say that 4, which is a real answer, and a are the zeros, 4 is not a 0 of this. So choice 2 is not our answer either. All right, let's go on to 3. So f of x has zeros of positive and negative 5 and negative a. Okay, so let me set that equal to 0. And I'm just going to make a t-chart and solve. So this time on the right side, we get x equals negative a. And then on the left side, if we take that and set it equal to 0 and solve, we would first subtract 25 from both sides, leaving us with x squared equals negative 25. And then look what happens again. When we take the square root, we again have a negative under the radical. I'm just going to put an arrow from this. So that is also a non-real answer. So choice 3 doesn't work either because we don't wind up with a positive and negative 5. We wind up with negative a and non-real answers. So Choice 3 is also out. So choice 4 has got to be the answer, but let's just double check. So if we take choice 4 and set it equal to 0, we can do factor by grouping. So I'm going to pull out an x squared, which leaves me with x minus a. And I'm going to pull out a negative 9, which also leaves me with x minus a. And when I group together the x squared minus 9 and bring down the x minus a, my 9's kind of look like a's. I'm going to make a tail on my a so it's clear which is which. We'll realize that, let me just move this up a little so I have more room. We'll realize that this right here is dots, so we could factor that further. So that'll be x plus 3 times x minus 3. I'll bring down the x minus a and make our t-chart. All right, so we wind up with x equals negative 3, x equals positive 3, and x equals positive a, which look at that. That is what choice 4 says. So that, after all that work, we finally found our answer. Okay, and finally number 17. So consider f of x. So they give us a function and h of x defined by the graph below. So I guess this graph right here is h of x, and we need to graph f of x in our calculator so we could see what it looks like. Okay, so I graphed f of x in the calculator, took a picture, and this is what it looks like. Now it says determine the difference. That means we're going to subtract between the values of the maximum of h. So here's the maximum of h. We could see, it's kind of hard to see these numbers, but it's 1, 2, 3, 4. It's at a height of 4. So the maximum of h would be 4. And then minus, it says the minimum of f. So here, I can't tell exactly where that's at, just by sight. So what I'm going to do is in my calculator, I'm going to do second trace maximum. Okay, so I'm hitting second trace and then, actually minimum, trace 3. Okay, so now we know we have to do like a left bound. So if this is the minimum, we need to move the cursor somewhere to the left of that point. So I'm going to use my arrow key and go to the left and hit enter. Okay, now it says right bound, so I'm going to use my arrow key and go to the right of that minimum point and hit enter. And we know we always hit enter on guess. And the minimum value is right here, okay, the y value, so negative 3.8. Okay, so from this 4, we're going to subtract negative 3.8. Well, minus negative is the same thing really as 4 plus 3.8, right? So the difference between this height, of the height of this maximum, and the height of this minimum would be equal to 7.8 units.